Good morning, students. In today's digital electronic class, we are going to deal with the concept of Verilog HDL code. In the previous class, we talked about the concepts related to sequential circuit, in which we have discussed the four types of flip-flops. Before going for the flip-flops, you may have a lot of doubts regarding what is a sequential circuit. That sequential circuit, we already discussed that sequential circuit is a circuit which depends upon storage, right? So how the storage is going to be do it, that can be done by using the flip-flops. So what is a flip-flop is all about? Flip-flops is a storage device which can store a bit of information, either it can be 0 or it can be 1. So to design the flip-flops, we do have three methods. One is by giving the clock pulse. We have seen how the clock pulse is going to be do it, then by using the latches, right? So by using the latches, when you want to see it, it can have two things. One is the NOR gate latch and another is NAND gate latch. By using these two latches, we have designed SR flip-flop, JK flip-flop, toggle flip-flop and D flip-flop, right? So in D flip-flop, we have connected one. It is D flip-flop and toggle flip-flop, both are unary operators. Unary bit, where it is going to take only single bit. What is the single bit means what? It is going to take only the one bit. It has the input is 1 and the output is Q and Q bar, right? So what is the sequential circuit of that? That depends upon how we are going to get the present state. If you want to take the next state, Qn plus 1, that we have designed by using the characteristic table. So these all concepts we have discussed in the previous class for D flip-flop, toggle flip-flop, SR flip-flop and JK flip-flop. So for SR flip-flop, we have done by using the NOR gate and NAND gate. So NOR gate is what? Active high, NAND gate is active low. Means when S is equals to 0, that is called set bit. For R is equals to 0, that is called reset bit. For NAND gate. For NOR gate, what is that? It is active high. Active high means when set is equals to 1, that condition is called set condition. When reset is equals to 1, that is considered to be the reset condition. So that is by using the NOR gate latch, we have discussed those concepts. Now let us come to the today's topic of discussion would be the hardware description language. So what is this HDL? So HDL is used to design the VHDL code, that is called Verilog hardware description language. So what is it hardware description language is all about? This is also one of the type of your high level language which can be understood by the computer and human being easily. Why we are saying it's so easy for us to design, and it is very easy for us to understand also, because the point what we are saying, since we are considering digital systems should have the zeros and ones. So it is going to be designed by using the logic gates, AND gate, NOR gate, NAND gate, universal gate or NAND, NOR, everything, whatever gates we have seen, by using these all gates, it is going to design for all types of gate. It is going to design by using, it's a programming language, right? So we are saying that it is a textual form. Textual means what? We are going to type it. For coding part, we are going to type it like a C. For C, what is that? It is having some syntax. For inputs, how do we design the inputs? How do we get the outputs? How do we assign the arrays and all those things, functions? How the C language is there? In the same scenario, we are considering our hardware description language is also be there, and it is main concept of that would be the textual form. So it is going to be in text form, right? Next thing we are saying, since we are keeping as a documentation language. Documentation means what? We are writing codes for our hardwares. What is that hardware means? If I am using basic gates, suppose I am using AND gate. I do have two inputs. The output of this would be A into B is equals to Y, right? This is my hardware, right? So I can't take that hardware. I need to write that particular form for it. So how do we do it? On what basis I can do it? The thing is, first I need to document it. So for that particular thing, what I am saying, since it is a documentation language, it is going to use for suitable for both, for human beings and for the computers. It is very suitable. Reason is that we can easily retrieve. Retrieve means what? I can able to sense. If I do have AND gate, what I can say that AND gate have two inputs and one output. This is the things which come in my mind when I consider the AND gate. But this is the hardware, right? I can't take the gates of it, I can't take two wires, I'll connect with this and I just want to make it. This, if I'm doing, that would be the hardware part. But what I'm doing, I want to write the code for it. I want to go for simulation. I want to write the code for that. So to doing these things, I'm saying that for these specifically the HDL codes are used in IC. What is this IC? IC is nothing but integrated circuits. For designing the integrated circuit, where it is useful? It is useful for data entry, design of the data entry or design entry. So for designing part, whenever we had any particular designing, we are giving some names for it, A and B. And we just have some user defined and which we had predefined. So predefined means what? There are two things in it. One is predefined. Second is user defined. So user defined is what it is actually. User defines are variables. It's similar to like variables. How you declare the variables in C language. In that same way, user defined is also be decided by the programmer, that what are the input bit. This is I'm deciding, right, the A and B. This is called user defined. So when I mention, instead of this gate, if I'm mentioning AND like this is called keyword or predefined primitives. So here the term what we are considering for AND, OR, NOR, NAND, all those things, that is already there. That is a keywords from the library of the HDL code, right? So those are considered to be the predefined. It is already defined in the library. From there we are linking the values. So those are nothing but like predefined by the HDL code. So that's the reason we are saying it is used for ICs, design entries, in which it may have two things. One is predefined, user defined, and functional simulation. What is the simulation means what? We had these, so instead of one gate, if you had multiple gates, like when we go for gate level designing of any kind of Boolean logic or Boolean equations, we may get a complex circuitry. Those complex circuitry, we need to write the codes for it. So that is the things what we are doing. The hardware we are converting into the programming language code. So that point is considered to be the simulation, right? So it is used to design the design entry in the integrated circuit, and it is used for the simulation of their functionality, and it is also used for their various purpose, logic synthesis and fault simulations. What is this fault simulation means? When you're designing this particular thing, you may get a lot of errors. So in order to come out of the errors, you may require fault simulation. So it is also useful for that purpose as well. And and one more thing what we do have is, it is also used for clock pulses, like we had the clock pulses, right? So this is called as timing sequence. To generate the timing sequence, your HDL code is going to be used. So for these all various purpose, we are going to design the functional simulation, design entry, and by using the fault simulations. For all those purpose, your hardware description language or VHDL code is being used. Next thing is that, how do we design the module declaration? So that module declaration means just like a syntax. So to get the syntax overview, first thing we need to keep in our mind that to design the syntax, what are the things we are going to do it? We are going to understand what is the user defined and what is a predefined. That means what is the variables and what are the keywords. As I am comparing this particular language with C language, since in C language we do have certain variables are there, certain predefined keywords are there, right? For that particular thing, if I want to design the module, here what all the codes we are writing, those are considered to be the module declaration. Because in that, if I want to start the programming code, the first thing I need to write over here is module with name. What kind of module name you are going to write? Suppose I just now took the example of one AND gate, right? So A and B. Y is equals to A into B. This is my AND gate, right? So this module, the name, what name I am writing? I am writing simple AND gate. This is my user defined. So I am writing the code for simple AND gate, right? Next thing, at the end, when you stop the things, it is called end module, means your program is going to terminate over there. So this is what starting and ending of the program in HDL. For that particular thing, we are using module and end module. Next thing, we have to declare what is the inputs and what are the outputs. So these are like a normal keywords. We also able to understand in the HDL code also will use the terms called input and output. So how many inputs I do have? These are my inputs, right? So I'll define inputs. So inputs are A, comma B. I'm using two inputs with semicolon. So this is a declaration, how we declare the inputs value. So tell me what is the output? So inputs are A, comma B, output is Y, right? The next is wire. Wire means if you had, instead of one gate, if your multiple gates are there, we need to write wire 1, wire 2, wire 3, wire 4. Different wires has been used. Since I'm not using anything, so output, I wrote it, inputs, I mentioned it. Next thing, I need to declare the AND gate. So what is that AND gate? I need to directly write AND. When you're declaring any particular gate, that should be there in the form of output followed by input. So what is output? Y, comma, A, comma, B. That indicates the first one is the output. The next two term is the input. So we wrote it, the AND. This is what this is the steps you need to follow when you're declaring any particular hardware into the simulation of that particular HDL code. So I have taken the example of this particular part in which I am declaring the program for HDL. In HDL, the first declaration is for these two things. The starting of the program, like in the C language, we'll write hash include, that indicate that particular library. stdio.h, conio.h, will indicate that our programming is going to be start from there. That is the header files, right? Over here in HDL, we don't have any particular header files. Directly, we'll start from the module and with name of the module. This is what predefined, this is the user defined. Next thing, we need to declare inputs and outputs. How many inputs you are using and how many number of outputs is there in your circuitry, because when we design the hardware, you may get a lot of circuitries. So what thing is, we need to design the inputs and outputs, we have declared it. The next particular part is what? If I'm using one gate, we have to gate name we need to write, because these are keywords. And, or, not, even you had NAND, NOR, etc. Right? So those are directly we have to use if you do have XOR also. So these are what actually, these are predefined. Now if you had supply 0, supply 1, that means if you're giving, instead of using this gates, if you're giving the supply for your BJT or FET working as an amplifier, where we had a plus VCC, supply and ground. So this is what? Supply, this is your ground. So supply 0 is ground, supply 1 is plus VCC. It can be a 5 volts, depends upon your circuitry. We may define these two things. Likewise, we do have registers, assign and always. They are different operators. In HDL, we have two types of modeling. One is data flow modeling, another is behavioral modeling. So this two way we do have, it's there for the EC students. When we go for the VHDL coding, for that particular part, we are going to use this two things, assign and always. For you, as of now, you have to know all these keywords. So you should be familiar with the keywords, and we'll write certain programs for your basic gates, and we may end up with that. So students, next we do have, how do we write the coding for this VHDL? For write the coding, what we are doing, we are considering one example. This is a schematic way. How do we write it? So we are saying that relationship of your Verilog HDL code. Verilog HDL full form is Hardware Description Language. So this is called VHDL. So V stands for Verilog, VERI, Verilog, Hardware Description Language. Okay, so we are writing how it is going to be used and how it is going to correlate the values by considering the example. So here we have taken relationship of Verilog HDL code with truth table, Boolean equations and schematic. Schematic means what? The timing sequence like ones and zeros. So this is called what? This is called as schematic, a timing sequence of that particular part or timing diagram. So how it is going to correlate? Suppose if I am having Verilog module, this I am considering, it is going to correlate into three particular form. One is for user defined primitives. What is the meaning of user defined? The programmer using the variables by its own definitions. So those are user defined primitives like A, B, C, D if I am defining by myself. So these are not what? These are the user defined primitives. So it is going to correlate with it, and in that what is there actually? It is there the truth table. What is truth table means what? If I may have A, B, C like this, I'll write the output for it. So this is what combination I'll take 0, 0, 1 till 1, 1, 1, 1 I'll take. So it is going to, Verilog code is going to correlate with the truth table by using user defined primitives, by using this defined. So these are called user defined primitives. By using that one, it is going to correlate with the truth table. Similarly, Verilog module, if you had continuous assignment, what is the meaning of continuous assignment? If I'm using your flip-flops, qn plus 1 if I want to write, if I do have D, if I had qn plus 1 is equals to T exclusive or with Q. Likewise, we do have a characteristic equations, right? So those are nothing but like a Boolean equation if you want to consider. So those are Boolean equations. It is going to correlate with the Boolean equation that is called continuous assignment operators. We may use it for assigning some operations. So that's what Verilog HDL code can correlate with that one. It is bidirectional. These two arrow mark in the sense it is going to give the input to it and it is getting the output from it. So both the way it is going to work. Likewise, we had primitives, that is nothing but gates. That means it is predefined. For predefined primitives we do have, here we do have user defined, that is our gates. Gates are AND, NOR, NAND, OR, NOT. So these are what actually? XOR, XNOR, all those things. So those are gates only. That already defined from the HDL. So that those are nothing but like a keywords over here. So those are primitives by the gates. So that is going to be correlate with the schematics. So it is going to correlate with the equations. This is the way the flowchart is going to work, in which the Verilog module can correlate with the truth table. It is going to correlate with the Boolean equations, and it is even going to get the connection from the primitive gates. These are like a chain we do have. That is how your relationship of Verilog construction from the Boolean equation, from the truth table and from the schematic has been written in this manner. So this is just introduction of it. So we'll see the example. How do we write the code for it? By taking one example for Verilog HDL code. So before it, just note it down, this particular thing, the schematic of it. So now students, let us take one example. Write VHDL code for given circuitry. So we are writing write VHDL, Verilog HDL code for given circuit. This is a circuit is given. We have to write the code for it. So basically, as you can see here, so AB are the true inputs given to the, what is a gate here? This is your AND gate. Similarly, C is given to the NOT gate and G3. G3 is coming the output from this one. Suppose I am saying this is what? Wire W1. Because I want to define it, right? So here is E is the output for this end and D is the output for that particular end. So we know this is our module, right? First thing what I need to write? I need to write initiate that one. So I am writing as module, right? I wrote the module. So when I am writing the module means it indicates our program is going to start from there. Okay, so I'll write module since it is not given any name, I am writing module name is suppose simple circuit. This is my definition. The simple circuit with semicolon. Okay. Next thing, what is the next thing I need to declare? How many number of inputs and how many number of outputs. So I need to define number of inputs and number of outputs. So for that, what I'm writing, I'm defining output and then I'm defining input. So I'll write output. So what is the output? So output, tell me how many is there? D and E. So output D comma E. This is output is done. Next, inputs. So how many inputs we do have? So input is A, B, C. So A, B and C. Right? So A, B, C is there. Again I can write W1 is output for this gate also. That is optional. You want to write or you don't want to write, because this is I have defined, not there in the question. Right? So what are the thing is done? Module is done and module will write at the end. Input and output declaration is done. Next thing, we need to mention, do we had any particular wire in it? So that means I'm using one wire, right? So I need to define the wire. So what is the wire I'm using? I'm using wire name is W1. So I'm separately defining this one, right? Wire have used because I have defined, because this is connected to the output of it and it is passing the input of the next OR gate. For that particular thing, I'm mentioning wire instead of writing over here output, since it is also output for this particular thing, but it is not end of the circuitry. Ending is there. This is the actual outputs we do have, right? These are our inputs. So those are internal connection. This is internal connection. This is also internal connection. I can define a W2, wire 2, wire 1. Why I'm not using? Because directly E is there. This is E means this is also E only, right? So that's the reason I'm not defining there another wire. So next thing, wire declaration is done. Next, I need to declare the number of gates. So how many gates we do have? Gate 1, gate 2, gate 3. Gate 1 is output is W1, inputs are A comma B. So what I'm writing? I'm writing the output followed by inputs. I'm defining the gates for all these 3 particular basic gates. So I'm writing the gates. What is the first gate I am using? I'm using the gate 1. So for that gate 1, what is the output I'm having? I'm having the gate 1 is, I'm defining what is the gate 1, and gate 1 is G1. So G1 of output. What is output? W1 comma inputs are A comma B, right? This is first gate. Second gate, G2. So G2 is what type of gate it is? Not. This is what keyword? Not G2. What is the output for it? E only, right? E is there for this also. It is passing to the next end. So here E. E is the output. What is the input for this? C. Next gate. What is the next gate I had? G3. So G3 is what type of gate it is? OR gate. So OR of G3. Output of this will be D. Comma. Input of this is what? W1 coming from there and E is coming from this end. So I can write it as C complement, or I can write this end because E is there for this particular part. So I can write even E also, or else C, and this is what? C complement. So when you want to write complement of it, I will write negation. This is where we can write negation of C. It depends on you. I'm writing E because this is the input for this also, right? So we have defined output, inputs, gates. Next thing, what is there left out for us? We need to end the module. So what I'm doing, definition of all the gates is done and the module is done. Next thing, I need to just complete the module. So what I need to do it? I need to end up the module. So what I'm doing, end module, right? Now this is the one example we did. This is what our definition, right? So this is what optional, because we are writing W1, right? So we are defining this is what optional gate. Comment I'm writing optional gate of W1 wire output, for you to understand why we are using W1. Clear? So once again, see students, so what are the things they gave? They gave G1, G2, G3. 3 gates are given. First we have to declare inputs and then output. So what I'm doing, I'm declaring output and input. You can declare input output anywhere. It's not necessary that output should become first, input should become later. Not like that. So output, input. These are what? Keywords. Predefined. Likewise, we have to define the next number of connections. What I'm doing? Internal connection. So we are having one wire I have used. So it's what? W1. So W1 of, it's a wire 1. Likewise, and and this is gate. What is the output here? W1. Inputs are this two. So output followed by input. That should be followed. That is must, right? What is the gate name? G1 of this. Here we don't write parenthesis because this is not a function. This is not the function for our VHDL code designing, because functions are gates, right? So and or not, like that we did, and we wrote the end module. Clear? So this is the way we will write the codes for given specifications or given module. So same way you may try another kind of questions. I'll give one more to you to understand and practice. I'll give you try this question and get me the answer through the mail if you had a doubt for it. Okay, I'll give one more question for you to write it down and try by yourself. Suppose the gate is like this. So this is a gate 1, gate 2 and gate 3, right? Here A, B, C, D. This is your E. Suppose having YW1 and YW2. Write VHDL code for it. VHDL code. Okay, that's the second question. So that one you try and get me the answer. So G1, G2, G3. This is your E, right? Write the code for it and get me the answer. So before doing that one, you noted down this VHDL4 code for this given condition, and you can proceed for the next question.